Welcome to Alchemist Camp. This is where we learn Elixir by building things. And today is a special episode. We are going to start building the website alchemist.camp, which will host all of the videos that you've seen on this channel. Well, not host them exactly. YouTube is hosting them, but it will contain and organize and add value to all the videos. I'll put show notes up next to each of the videos. I'll put links to code or embed code that in a way that you can copy and paste it into your own projects. It's really going to be the hub where you can find all the stuff that's on this channel right now. Since the whole point of Alchemist Camp is to help people learn Elixir, it seems crazy to me that the website is not running Elixir right now. So we're going to fix that. Let's take a quick tour of the architecture of some other frameworks you're probably familiar with. Rails has got to be the most famous. As of 2017, there is no framework out there that can get you moving on a new project and develop a web application as quickly as Ruby on Rails. That was also true in 2016, 2015, 2014, and pretty much all the way back to when Rails was first made in the mid-2000s. Rails is built on top of something called Rack, which is a lower level library that does some basic HTTP handling for you, but it doesn't do much else. Like, you've basically got to write your own router and your own controllers, not just the controllers, but like the concept of a controller in order to do Railsy kinds of things with Rack. And it's not used too much on its own, but it's used to make other Ruby frameworks. Like Sinatra is a famous one that's much simpler than Rails, and it handles your HTTP responses, but it takes care of more of the details than Rack does. It's kind of like Express.js is, and it's built on top of Rack, and so are several other frameworks that people have made. And Rack can run on a variety of different web servers. Passenger, Puma, Thin, Unicorn are all examples. Puma is probably the most popular one, but it doesn't really matter. You can mix and match, and similarly, Rails can work with a variety of different databases. So there you have it. That's what Rails looks like. Here's a Node stack. So Node is the web server that everyone uses with pretty much any JavaScript stack, and it's a little different from Puma or Unicorn or those web servers, because Node is essentially just a JavaScript interpreter that has the ability to receive HTTP requests and do basic things with them. And I mean very basic. Like, even if you just want to set up some routes, you'll still have to deal with HTTP options and some low-level details that most web developers never even want to think about and might not even be aware of. Then Express is built on top of Node. It's still pretty low level. It still doesn't have the concept of a controller or a model, anything like that built into it, but it's got a simple templating language, and it'll handle some of the really low level details, and you can start setting up how it responds to various routes. Then Sails is basically a clone of Rails. It was made by people who really liked Rails and had moved to the JavaScript world, maybe because of how popular Node has gotten, very likely because of performance issues they had with Rails. Maybe they were making a chat room or something like that that has to deal with a lot of evented activity. But the point is, it's very Railsy. Like, it includes the idea of controllers, it's got an analog for Rails views, it's got working with a database is something that's built into it. It does some things Rails doesn't do, like it handles WebSockets, and you can do some neat things with that. So this is an example of a stack, but there are many other web frameworks that have similar things going on. Like with PHP, you'll generally be running either Apache or Nginx, and then on top of that, you'll have a framework, some of which are also Rails clones, like Cake PHP or Laravel, something like that. If you're using Java or Scala, you might have the Play framework on top of it. These are just examples to give you an idea of the context for looking at Phoenixes. So Phoenix is a high-level framework that does a whole lot for you out of the box, like actually more than Sails, more than most other frameworks I know of. Not as much as Rails. It doesn't have a mailer built into it. It certainly doesn't have all of the magic of Active Record built into it or something like that. But it is very high level, and it is very rapid to develop in. And it's built using something called Plug, which has a whole bunch of utilities for working with stuff a web server has to work with. Like Express, you could build websites just with Plug, and you'll get a little bit better performance if you do so. But it's not the huge performance difference that you would see between Rack and Ruby on Rails. Phoenix actually does not cost very much in terms of performance over what Plug does. It's just because of the way it's designed. It didn't have to lose much. Then Cowboy is the web server, and it's the only web server Phoenix can use. So you're going to be running Cowboy. You may not be looking at it much, but you're going to be running it. And Cowboy is written in Erlang. It's an old project that predates Phoenix by quite a bit. In order to build Alchemist Camp, we are going to start with Cowboy. And with Cowboy, we're going to build more and more utilities. And those utilities are going to do a lot of the same things that Plug does and a lot of the same things that Phoenix does. And in the process, we'll see what some of the inspiration for Phoenix was. In one sense, I think you don't really understand what a framework does for you until you try to work without it and encounter the problems that it was designed to fix. So let's get started. As usual, we'll open a terminal and we're going to mix a new project. We'll call our website Campsite since it's for Alchemist Camp. Mix new campsite, and unlike before, we're adding a --sup flag to it. That sup or soup stands for supervisor. This is not just a simple mix application like we've done before. This is an OTP application that can supervise child applications. So we'll open up campsite and cd into the directory. And you may notice that we've got our campsite.ex, which is the same kind of default stuff we'd always have, but we also have a campsite directory and a file in it already called application.ex. I'll clear out these comments because they're just telling you where to get more information, and we're going to go over everything. We've got a start function, which is crucial. We're going to look at our mix file first, but we'll be right back here in a moment. So in our mix file, we have an application block, and in it we have extra applications, logger, which we've seen before, and we have mod, which stands for module. This is the entry point for our OTP application, this campsite.application that was created for us, and the app will start at this start function. Then we need to add a dependency for the Cowboy Web Server. Cowboy had a pretty major update at version 2.0. It started supporting HTTP 2 and a bunch of other things. Phoenix was written based off of Cowboy 1.0 and only very recently started supporting 2.0. So we're going to stick with 1.0 and keep things simple for now. Then we need to mix deps, and we'll mix to compile all of that Cowboy stuff. And while that's happening, we'll look at our application file. So our application has the function start, which is required, and there's a type, which we don't need to worry about, and arguments that get passed to it in a list. And we also haven't passed any arguments. The application will start this list of children, i.e. none, when it starts, and The strategy is to how to handle it if the children applications crash. And one for one means that when a child process crashes, the supervisor will restart it. There are actually 4 strategies. There's a simplified one for one. There's one for all, or there's an all for one, I should say, where the supervisor will kill all of its child processes if any of them crashes, and then it restarts them all. And there's a rest for one. Right now, this also doesn't matter because we don't have any child processes. We're going to start the Cowboy Web Server, and we'll make a function to do that. And we'll define it down here. And no arguments. And we'll just name a couple of routes, so just make them up. Route 1 is the root of the application, and we'll call it campsite.web.pageHandler, which we'll have to define in a moment, and we'll pass it no options. And we'll just make a copy of this route, call it route 2, and it'll be at 2 and no options again. Then we'll put those routes together and call Cowboy routers compile on them to make a dispatch. And we need to pass it a list that has 2 elements, or a list that has one tuple, I should say, and the tuple has 2 elements. The first one is the host name, and this underscore symbol, or this underscore atom, just means it'll match any host. And the second element is a list of all the routes. And all right, then options, we'll set the port in here, set it to 4000, and the environment. And that's just a key value pair of dispatch and dispatch. Then we'll start Cowboy and we'll wrap it in a case statement in case it doesn't work. So first we're saying that it's going to be HTTP. Then we'll specify 10 processes, which is how many it'll start. And we'll pass in options, which is just the port. And then we'll pass in the environment, which holds our routing information. And the Cowboy server should return an OK and a process ID. The process ID you use to keep track of the process, and then other processes can communicate with it. We're not going to do that in this case. We'll just put Cowboy is now running. Go to HTTP localhost 4000. And if it doesn't work, which is basically getting anything but an OK and a PID, there was an error starting Cowboy Web Server. Okay, we'll save that. Now it's time to make that page handler. We'll go into campsite and make a directory called web. We'll make a file called page handler. .ex. The page handler will be called campsite.web.pageHandler. The page handler must define 3 functions: init, handle, and terminate. Init is what it does when you start it up, and it first takes a tuple that should be TCP HTTP because we told Cowboy start to use HTTP, and then a request, and then options. And these options come from the route here, and we're not passing any options at all. So that's just going to be thrown away in this case. Then we return a tuple with OK, the request, and the state. And we're just going to say empty for the state. This is just an atom that I chose, but if we had state, then we could pass whatever state we want to along to the handler. The handler takes the request and the state, which is empty in this case, and then it builds a reply. And we'll use a variable to keep track of our headers, which are just going to be content type text HTML, and the body will be an H1 tag. Welcome to Alchemist camp. Then we'll build the response with a function in Cowboy rec called reply. 200 is the type of response, means everything's okay. Then the headers, the body, and the request. And then we will return an OK and that response and the state. And terminate. Has a reason, the request, and the state. And we're going to throw all of them away and just say OK. All right, let's fire it up with IEX mix. Excellent, says it's open. Welcome to Alchemist camp. Now let's see what happens if we go to a different route. We have nothing. So let's extend this a little bit. First, we'll go into our application and make some more routes. So, oh, we do have a route number 2. So that probably, yeah, so we would have just gotten the exact same response since we passed no options then, but now we will. We'll call this base, and we'll call this 2. And we'll make some more routes. We'll make a contact and then we'll make a secret route because Easter eggs are amazing. And the route will be up, up, down, down, left, right, BA, because that's what I would expect to lead to an interesting place if I were just looking at some web page. And we'll call this route 3, this one route 4, and route 3, route 4. And actually, let's make it 5. Let's make one that handles everything else. So that's going to be the atom underscore, which is the wildcard route. Save that. All right, we'll go to the page handler and we'll modularize this a little bit. We'll make content 4 base, and we'll steal this body here. And we'll make one, and we'll, instead of calling body here, or instead of passing a body in, we'll just use content for state. And here will be state, state, state. All right. And now let's make a content for 2. And content for contact. You can find us on Twitter at Alchemist Camp. Then finally we need, we need 2 more things. We need the secret page. Content for secret. You found the secret page. And the content for everything else. I think we called that others. Oh, we should have called it others. Sorry, we don't have that page. Okay, now let's mix this up again and see if it works. Cannot invoke local content for inside match. It is the handler, line 13. Oh, so we got double defs in here. That's not good. All right, it's running, so let's give it a look-see. So we still have the original. We have 2, and we have the missing page, and we have up, up, down, down, left, right, BA. Okay. And let's see if we can also the contact page. Goes to Twitter. Yay. All right, we're going to deploy it. And then next lesson, probably do this again. I think I'm going to put off the conclusion of tic-tac-toe for a while. And we'll just deploy better and better versions of the site because it's gotten to the point where really got to throw up some kind of website for all these videos. It's been a pleasure sharing the very beginning of Alchemist Camp with you. And if you have any questions about anything so far, feel free to leave them in the comments. And if you're interested in this, definitely click subscribe, click the bell so you get the updates. And I will see you next time.